Hi everyone, in this video we are gonna talk about will AI replace developers and also the evolution of how developers write code. 20 years back, we never thought our lives would shrink onto a handy rectangular device called a mobile phone. Same way, after 20 years, who knows what changes technology will bring to us. For sure, it will be beyond what we see in science fiction movies. When we think about technological advancement, we cannot ignore AI. No doubt, it works like a magic in a fraction of a second wherever it is implemented. Some of the uses of AI we enjoy in our daily lives are virtual assistants like Alexa and Siri, self-driving cars, surveillance cameras, recommendations given by Netflix, Amazon and YouTube, chatbots, devices we use in smart homes, voice-to-text converters and so on. The list is endless. In the software field, it's clear there's a lots of buzz about the question, will AI replace developers? Before diving into this question, let's look at the evolution of coding and how developers write code. In the beginning, source code was written on punch cards. Yes, a card with holes represented the source code. Back then, secondary storage devices like hard drives were not developed, and punch cards were the primary way to store and load the data and programs. Let's see how they wrote and executed a program. The first step was writing the program manually on a coding sheet by a programmer. Then, the coding sheet was given to a punch card operator. The punch card operator would then allocate one card per line of the program. A typical punch card had 80 columns, with each column representing a character. The operator punched holes in each column based on the character. So, a total of 80 bytes of information could be stored on each punch card. At the end of this process, the programmer got a deck of punch cards. This deck was fed into a computer to execute the program, using a card reader connected to the computer. From writing the code to execution, the whole process took almost a day. Let's take a simple example of a calculator program with the basic operations like add, subtract, multiplication and division in the Fortran language. Imagine this, back in the day in 1970s, there was a developer named John. He needed to create a basic calculator application. So what did John do? He wrote the entire program on a coding sheet and handed it over to a punch code operator. Check out John's code for this calculator, written in Fortran. It is in Visual Studio Code, but back in those days it was all done on paper. The punch code operator took John's code and told him, John, your program has 22 lines, so we need 22 punch cards, one for each line. Then, using a punch card machine, the operator fed each punch card and punched holes per column, matching each character in a line. Finally, all 22 cards were done. The operator handed back the stack of 22 punch cards to John. Now this deck of cards was like John's storage device for his calculator application. So John needed to run his program. So he headed over to the computer room and fed the deck of punch cards into the card reader connected to the computer. The computer scanned through the deck and ran the program. John would get the output on a printed sheet. But if there were any mistakes in the output, John had to take that printed sheet, go through it carefully to find the error, and then correct the mistake. After that, he had to go back to the punch card machine, replace the mistaken punch card with a new corrected one, and repeat the process. It's absolutely a nightmare for a modern developer. So at the initial stage, the developer like John had to focus on writing the code properly as well as the logic part of the code. Then terminals and text editors came into the picture. They drastically reduced the overall time from writing to executing the program. But the focus of developers remained the same. They still needed to focus on programming on logic. We all know about IDEs like Visual Studio, Eclipse, PyCharm, Android Studio, NetBeans. They come with advanced features like IntelliSense. As we type the code, it shows a list of all the accessible members of variables and methods in a project. Along with this, it highlights syntax errors and provides quick fixes, allowing developers to correct mistakes as they type. It also suggests names according to the naming conventions of the respective programming languages. In tooltips, it provides all the details about code elements in a program, like data types, return types, and documentation comments. Developers can run, debug, and test their code with just a simple click. Overall, modern IDEs enhance the coding experience of developers like John by providing real-time assistance and reducing the need to constantly refer to external documentations. So our developer like John feels typing code in an IDE is way more luxurious than typing in text editors, making the coding process much easier compared to stage 1. It gives John more room to focus on the logic rather than the coding itself. The time and effort required from developers have been significantly reduced and the productivity has increased. Right now, we are in the age of code AI along with low code and no code platforms. By adding this to your developer's toolkit, whatever you ask, it can whip up complete code snippets in just a few seconds. It totally gets rid of manual coding. For example, if our developer John asks Code AI to write a simple calculator program, it will spit it out almost instantaneously. It can also translate programs from one language to another effortlessly. Like if the calculator program is Java, and if you want it to convert in Python, it can do that in a flash. Code AI also optimizes code and finds bugs in no time. Some big names in Code AI are GitHub Copilot, Tab9, Amazon Code Whisperer, ChatGPT, and so on. So how about low code and no code platforms? These are the new cool in the tech world. Low code platforms let you create apps with minimal coding. They have drag and drop features and pre-built components, but you can still add custom codes if you want. It's great for speeding up development. For example, platforms like OutSystems and Mendix let you build complex applications quickly without writing a lot of code. No code platforms take it even further. You don't need to write any code at all. It's all visual with drag and drop components and templates. It is perfect for business users or anyone who doesn't know how to code but still wants to create apps. For instance, tools like Airtable and Bubble allow you to create fully functional apps just by dragging and dropping elements. In stage 3, Code AI, low code and no code platforms have really cut down the effort of our developer John for coding and writing logic in development. So in this stage, what should developers like John be focusing on? Are developers getting sidelined? Bringing us to the big question, is AI going to replace developers? To sum it up, from stage 1 to stage 3, the amount of effort developers need to put in coding and logic has almost gone down to 0. The real question now is whether this change is making the developer's role better or is it pushing them out of the picture. The answer is a big no. AI won't push developers out of the scene. But how, you ask? Catch the next episode to find out why AI is not going to replace developers like John.